Hi everybody, it's Mrs. Hannah Farth and I'm here to take us through Lesson 9, Standard Form and Factored Form. Our learning objective today is going to be students are going to be able to know the difference between a factored form and a standard form, and then you are going to be able to rewrite quadratic expressions given in factored form to standard form, either using the distributive property or a diagram. So on this very first page, you're going to note that I've got an example of standard form. So right here, this is standard form. Notice we know that it's a quadratic because of the square on the x, or the x has got a squared term on it, or the exponent is 2. Down here is, we have standard form right here, and you can see right here we have factors. So these two parenthesis terms are factors. I know that they are factors because they are multiplying them together. So the very first thing that we are going to be doing is we're going to be continuing our lesson from last week. This time we're going to be finding the products of differences. And differences, I need to remind you, has to do with subtraction. So again, remember we've got subtraction when I talk about the differences. And this time we're going to layer on, and we're going to remember some of the properties about multiplying negative numbers together. So when I multiply a negative times a negative, we're also going to be multiplying negative and positive numbers together. And then from there, we're going to be adding and subtracting positive and negative together. So let's start by doing the very first example that I've got here. And we are going to be looking at x minus 1 times x minus 1. And the very first thing I'm going to do is I'm going to tell you that we have a factor and another factor. And those factors are x minus 1 and x minus 1. And we are going to write the equivalent expression right here, and that equivalent expression is going to be written in standard form. And last week we learned how to take an area model and do that. So I'm going to go ahead and draw a rectangle, and I am going to write my side lengths of x. Note that I use minus 1 and x minus 1. And now I'm going to simply multiply these together. X times x is x squared, and I'm multiplying. And x times negative 1 is negative x. X times negative 1 again is negative x. And negative 1 times negative 1 is positive 1. I'm now going to add up everything inside, and I'm going to get x squared minus x plus 1. I am now going to combine like terms. Notice I underline the like terms in that expression. I'm going to get x squared minus 2x plus 1. I have just gone from factored form to standard form. So up here, I would write my standard form of x squared minus 2x plus 1. Okay, so there's one other thing I want to make note of is x minus 1, sorry, I'm going to use the same example from the previous one, and x minus 1. And we know that that's equivalent to x squared minus 2x plus 1. Again, I noted that this is the factored form. How do I know that? Typically what gives it away are two things being multiplied together, and they're usually encased with parentheses. Standard form is right here. And the correct way to write things in standard form is that we always start with the largest exponent first. So please note that that's a 2, therefore it goes first. And then followed by, notice that there is a 1 on that exponent, a 1 on the x, but we never write it. So that would be minus 2x plus 1. This is called standard form, and we always write it in a very specific way in order from the largest exponent down to simply a number. You're going to be asked to do this in a Delta Math assignment, and so I want to make sure you pay close attention to you start at the largest number and you go down in terms of largest exponent down to a number when you write the terms out. So moving on to our next example. These next 3 problems, we're going to be writing an equivalent expression for them, and I'm going to use an area model. I'm also going to be using the distributive property to show you. You can use either one. So x plus 1 times x minus 1. I'll start with the area model. I'm going to first draw my rectangle with my boxes. I know I've got x plus 1 and x minus 1. Now I'm going to go ahead and multiply x times x, which is x squared. I'm going to multiply 1 times x, which is 1x. I'm going to multiply x times negative 1, which is negative x. And I'm going to multiply 1 times negative 1, which is negative 1. I'm then going to go ahead and I'm going to simplify by rewriting all the terms inside. X squared minus x plus x minus 1. I'm then going to simplify and combine like terms, noting right here in the middle that if I have negative x and I add x, that becomes a 0. Therefore, I've got x squared minus 1. This is my standard form, and this is my factored form. I'm now going to show you how to use the distributive property to do the exact same problem. I'm going to go x plus 1 times x minus 1. And in this case, I'm going to use the rainbow method. So that means I'm going to go x times x minus 1 plus, now I'm going to go 1 times x minus 1. So I'm using the distributive model. This is x times x is x squared minus x. Now I'm going to go here plus x. And then 1 times negative 1 is minus 1. Again, I'm going to note minus x plus x becomes 0. Therefore, I'm left with x squared minus 1. Either way that you want to do it is totally fine. You pick a method. I personally find right now to really encourage you to use the area model, the rectangle, because it's going to help you keep track of all of your terms that are going on inside. It also helps organize the signs of your numbers. Okay, our next problem is going to be x minus 2 times x plus 3. And again, I'm going to draw using an area model. I'm going to use x minus 2 and x plus 3. Finding the area of each side, I've got x squared, I've got minus 2x, because minus 2 times x is minus 2x. X times 3 is 3x. And negative 2 times positive 3 is negative 6. I'm therefore going to go ahead and combine all my like terms inside by going x squared minus 2x plus 3x minus 6. Continue to simplify and combine like terms. I've got x squared plus 1x minus 6. So that's using an area model. If you wanted to use distribution, x minus 2 times x plus 3, I would start with the rainbow of distributing out x times the quantity of x plus 3. This time I'm going to pay close attention to that minus 2. So I'm going to go minus 2 times the quantity of x plus 3. Using distribution, therefore, x times x is x squared. X times 3 is plus 3x. Continuing to do the same, minus 2x, because minus 2 times x is minus 2x. And then negative 2 times positive 3 is negative 6. Combining like terms, right there in the middle, I've got x squared plus x minus 6. Okay, you can see we came to the same exact answer. Here's the last one we're going to do. We've got x minus 2 squared. You need to remember that that means I've got x minus 2 times x minus 2. Again, I'm going to draw my rectangle or my area model. I have x minus 2 and x minus 2. Therefore, I have x times x is x squared. X times negative 2 is negative 2x. X times negative 2 is negative 2x. Negative 2 times negative 2 is positive 4. Combining like terms gives me x squared minus 2x minus 2x plus 4. Combine my terms in the middle, therefore I've got x squared minus 4x plus 4. Okay, using the distribution method or the distributive property means I'm going to go x times x minus 2 minus, here's my next distribution, minus 2 times x minus 2. Therefore, I'm going to distribute this way. X times x is x squared. X times negative 2 is minus 2x. Negative 2 times x is negative 2x. And then negative 2 times negative 2 is positive 4. Again, you can remember my positive and negatives. Combine like terms. I'm going to combine the middle two terms, which leaves me with x squared minus 4x plus 4. So the next thing that I want to cover is, again, just to review the difference between standard and factored form. So again, if I were to make a table, so written in standard form, standard form, and my next one would be not written or not standard form, and I'll just write not standard form. Okay, and let's just jot down some examples of each. So this would be standard form, x squared minus 1, x squared plus 9x, 1/2 x squared, 1 minus x squared. So these are all in standard form. What kind of gives it away? 1, I don't see any parentheses. 2, I see my exponent of 2 on every expression that I wrote. And there's no multiplication, meaning I don't see anything shown with multiplication like that. So let's look at what not written in standard form. So this is written in standard. So this is all standard. So now let's look at what's not standard. So if I go 2x plus 3 times x, x plus 1 times x minus 1. 3 times the quantity of x minus 2 squared plus 1. So you look at that and you go, wow, these are all factors. So here's a factor times a factor. Here's a factors. Factors. I can rewrite this, right? Here's a factor times this. But notice it's not standard, and be careful here, not standard, meaning these are factors right here. They don't look anything like this over here. Okay? So just to close out our lesson, I'm going to ask you to do a couple of problems, and this will be part of the Ed Puzzle as well as other problems in the Ed Puzzle. So I'd like you to do the following. 2x plus 5 times the quantity of x plus 1. What I'd like you to do is write an equivalent expression in standard form. Okay, so this is factored to standard. All right, and the second one that I'm going to ask you to do is x minus 2 times x plus 2. Okay, and again, you're going to write that in standard form. So for my examples here, you could see what the final answer was. For the first one, 2x squared plus 7x plus 5. Note, again, the way that I wrote it, I started with the largest exponent first, then the term just 7x, and finally the number. This is the correct way to write it in standard form. Again, you'll note down here that I did 2x times x is 2x squared, x times 5 is 5x, 2x times 1 is 2x, and then 5 times 1 is 5, and then I added them all together, combined like terms, and I got my final answer. Same thing with the second example, x minus 2 times x plus 2. Notice here I filled in the area model the same way that I did previously. I circled these two terms in the middle, 2x minus 2x, because I noticed that those were opposites. And right down here, you could see that it became 0. So I'm left with x squared minus 4. So Miss King is going to take us through lesson 10. And your Delta Math assignment this week is all going to be more practice around doing area models and multiplying what is known as binomials.